In this video, we're going to look at growing annuities. The annuities that we dealt with so far all require equal regular payments. There are special cases whereby one requires an increase in the payment amount to offset the influence of inflation. A typical example of this would be a trust fund established to make annual disbursements sometime in the future. Consider the example where each year a trust is expected to make a disbursement, and to offset the influence of inflation, the payment each year is increased by a fixed percentage. We will call that G. An example of this is shown in the following timeline. Okay, so here we have our first payment at time T1. Then at time T2, we make an increased payment. It has grown by a growth rate of G. Then at time 3, the payment will again grow from the previous payment at a rate of G. So the third payment will be given by payment 1 plus G squared, and so forth. If we look at specific numbers, just as an illustration, let's say that our first payment is 500 rands. And the growth rate is 10%, so our G is 0.1 or 10%. Then our second payment will be 550. Our third payment would be 605 rands. Our fourth payment would be 665 and 50 cents, and so forth. So you can see that these payments are not equal. They grow at a fixed rate, in this case 10%. So when we are working with growing annuities, we would like to get the present value, a formula for the present value of a growing annuity. So to get the present value, we need to move each of these payments to the time period T0. So that means that we will move this payment, the first payment, to time period T0, the second payment, the third payment, and so forth. So if we write it out as a formula, you can see that we have the first payment, and then to move it back one time period, we multiply it with 1 plus I to the power minus 1, because we move it back one time period. Then the second payment is given there, and then we want to move it back 2 time periods. So that is why we multiply it with 1 plus I to the minus 2, because it moves back 2 time periods. The third payment is this one over here, and then we move it back 3 time periods. So we multiply it with 1 plus I to the minus 3, and the same for all the rest of the payments. So you will recognize this expression here as a geometric series. Just to remind you what a geometric series is, the first term is in a geometric series is A. Then the second term will be A times R, where R is a certain factor. Then the third term will be AR squared, then AR cubed, and so forth. And that is a geometric series. And if we look at this expression for the present value of a growing annuity, our first term will then be A. So our A will be the original payment times 1 plus I to the minus 1, or we can just divide it by 1 plus I. That will be our A. And then R is the factor with which I multiplied each of the consecutive terms. So R will be equal to 1 plus G, the growth rate, divided by 1 plus the interest rate of my investment. So my R is 1 plus G over 1 plus I. And if you use that, there's a formula available to find the sum of a geometric series, of a finite geometric series. If you substitute your A and your R into that formula, you will find this value for the present value of a growing annuity. So one can use this formula directly to determine how much should be invested for a fixed period with an annual growth rate G, fixed interest rate I, and to provide for K annual payments in the future. So let's look at an example. Example 48. A trust is required for a grandchild to enable them to pay for tertiary studies when they reach 18. The trust is structured to allow for annual payment growth of 10% per annum, and the interest rate is 12% per annum compounded annually. The first payment is due in exactly 1 year, and the first payment is set at 65,000 rands. Determine the amount that must be invested in the trust to allow for 6 payments. Okay, so before we find the original amount that needs to be invested in this trust, let's just quickly remind ourselves that because this is a growing annuity, the payments will also increase at a rate of 10% per annum. So my first payment is 65,000 rands. The second payment will then be, it will grow at a 10% rate. So the second payment will be 71,500. The third payment, 78,650, and so forth. If you would like to get the last payment, the sixth payment, then payment 6 will be the original payment, 1 plus my growth rate, which is 10%, 0.1, to the power, and now it's to the power 5 and not to the power 6. Remember, the sixth payment will here have the 1 plus G to the n minus 1, so it will be 6 minus 1, which is 5, and therefore my last payment will be the following. Okay, so my last payment will be 104,683 rands. Okay, so to come back to the original question, we would like to know what is the present value for this trust. So now it's just a matter of substituting all the information we already have. So the payment, the original payment is, or the first payment is 65,000 rands. The interest rate is 12%. The growth rate 10%. And we have 6 payments. So if we do that substitution, we get the original payment that needs to be made into this trust. Okay, so 333,000 rands and 34 rands and 21 cents. Okay, then the next example, example 49. A trust is established to make 5 annual disbursements, with the first disbursement exactly 10 years after establishment. The trust has secured an investment of 500,000 rands at an interest rate of 7.5% per annum compounded annually. And then to counter inflation, an annual increase of 5% per payment is allowed. And we would like to know what is the value of the fifth payment. So to illustrate this scenario, we can go to a timeline. You can see that the original investment is 500,000 rands, and the first payment only starts at time T10. So this growing annuity starts one time period before the first payment. So my annuity will start at T9. And therefore, to get the present value of this growing annuity, we first need to move the original investment of 500,000 rands. We need to move it to time period T9. So that is what we're doing here at the bottom of the slide. I take my original 500,000 rands and then I move it through time up until time T9. And this 0.075, remember, is my interest rate. So the value of the investment at time period T9 is this 958,616. 619. And we will use that then as the present value of our growing annuity. Okay, so here we have the formula for a growing annuity. In this case, we have the present value, we have the interest rate, we have the growth rate. Our K is equal to 5. So what we need here is to find the first payment. So we need to rearrange this formula so that we can solve for payment. So the payment will be the present value Okay, so we will use that formula then to find the first payment. And that is what we then have over here. I use for the present value this amount that we calculated on the previous slide, the value of the investment at time period T9. Then I've got my interest rate, I've got my growth rate, I have 5 payments, and therefore the first payment that will be made at time period T10 is given there on the slide. And now we would like to know what is the value of the fifth payment at time period T14. So we want to know payment 5. So payment 5 is the first payment, the original payment, 1 plus the growth rate, and then to the power not 5, but to the power 4. Okay, and if we do that substitution, we get the value of the last and fifth payment.